everyone, welcome to another video on how to remember pharmacokinetic equations in a quick and easy way. So most of the time we have several equations, especially during the exam, it is a very difficult to remember exact equation. So there are four equations. If you rearrange those equations, you are good to go with the pharmacokinetic calculations. So number one, volume of distribution equals dose over concentration. Just rearrange this equation number 2. The dose equals Vd times concentration. So this is the equation of loading dose. And also easy way to remember loading dose. The loading dose equals Vd. Also you see the rhyming. Loading Vd times C. The concentration of plasma concentration or target concentration or steady state concentration, all are same, don't confuse. Then divided by F, bioavailability. So most of the time the loading dose we give intravenously, so bioavailability F equals 1. But anyway, so in the exam, so whatever the F value is given, so you have to use that. Number 3, because we are talking about loading dose, just do the maintenance dose. So maintenance dose, you see, remember T. The maintenance dose always we give in the frequent interval. The maintenance dose mainly depends on the clearance. Clearance times, so the C is a common. Then, and also you don't forget the T, time interval, the times tau, that is the time interval, over F bioavailability. And the number 4 important equation of life. So T of equals 0.7 times Vd over clearance. So those are the four equations you must know for pharmacokinetic calculations. So let's do some cases or apply this knowledge to solve some of the problems. Okay, first one, if you see here, they're describing the patient condition. So here major focus, we need to calculate what is the most appropriate loading dose in this patient in the milligrams. Okay, so always remember the lead in what they are asking from this case, right? So they are asking to calculate loading dose for the given drug in this patient in the units milligrams. All right, what values you have? The body weight 50 kgs, BMI 24.5, and intravenous bolus dose. The concentration is a 5 milligrams per liter. Bioavailability is a 1. Volume of distribution 2 liters per kg. Maybe you can pause the video, come up with the answer, then I will work with you explanation. Alright, I hope you guys got the correct answer. So let me work it out. Okay, so the loading dose, we know that the loading dose equals, remember the D is loading Vd times concentration over F. So here what is the volume of distribution? The volume of distribution they given in the per kg. So we have to see what is the percent body weight, 50 kgs. So 50 kgs times 2 liters per kg. So that gives you 100 liters, correct? So the kgs will go away. 100 liters is the Vd. So now the plug the values in the Vd is the 100 liters times concentration is 5 milligrams per liter over F is 1. So 100 times 5 is 500. So liters will go away. That is a 500 milligrams. So that is way we have to calculate the loading. So let's the next one. So here, so we have 22-year-old man and the drug X, the plasma concentration is at 20 milligrams per liter, volume of distribution 70 liters, half-life is 60 minutes. So which of the following ingested dose? And also you have to look for what is lead-in is asking. Lead-in is asking for only the dose. Sometimes you have several pharmacokinetic parameters. You no need to apply all those values. Okay. So that means the dose means you think of you have volume of distribution, concentration. So that means we can use the volume of distribution equals dose over concentration. So we need to calculate the dose. So you have to rearrange the dose equals Vd times C. So what is the Vd? The Vd is the 70 liters and concentration is 20 milligrams per liter. 20 milligrams per liter. So liter goes away. The 20, 0, 20, 27 is a 140. So that is a 1400 milligrams. So you see here the 1400 milligrams. This is the correct answer. All right. And also make sure the units, the 1400 grams, that is incorrect. 140 grams, that is incorrect. 140 milligrams, that is incorrect. Got it? Next one. So we have volume of distribution 500 liters. Clearance is 240 ml per minute. Bioavailability 50%. And you have to calculate the loading dose. And with the concentration 50 micrograms per liter. So we know that the loading dose equation equals Vd times concentration over F. So that means here Vd is 500 liters, concentration is 50 micrograms per liter, and over 50% means 1 over 2. So that means the liter goes away. Then 500 times 5 is, that is a 500, 500, 5 5 is a 25, that is a 2500, and you have so this is the concentration is a 50, so that means so 25,000, correct? Then if you 1 over 2, that comes 25,000 times 2, that equals 50,000 micrograms, right? So 50,000 micrograms equals how much? That is a 50 milligrams, correct? So 1 milligram equals 1000 micrograms. Okay, so 50,000 micrograms means 50 milligrams. So that's the correct answer. So next one, we have 100 milligrams of dose administered intravenously 1 hour after infusion. The serum concentration is at 10 micrograms per ml. The volume of distribution is closest to which of the following? All right, so volume of distribution equals dose over concentration. So what is the dose administered? 100 milligrams, and the concentration is 10 micrograms per ml. So that means we have to convert milligrams into micrograms. So that is a 100,000 micrograms over 10 micrograms per ml. So what happens? These micrograms will go with the 1, then this is going to be 10,000 ml, correct? So this is a 10,000 ml. So that equals 10 liters. So that means 1 liter equals 1000 ml. So correct answer is going to be 10 liters. Next one. So we have a drug volume of distribution 100 liters, clearance is 7 liters. What is the half-life? So we know that half-life equation equal to 0.7 times Vd over clearance. So 0.7 times Vd is 100 liters over clearance is 7 liters per hour. So that means this is the 0.7, that is a 70 liters over 7 liters per hour. So 7 times 10, that liters go away, that's 10 hours. So the correct answer is 10 hours. Got it? So I hope you guys remember. Thank you very much. See you in next video.